let's get started with today's lesson. What we're going to talk about today is the inverse of the exponential function, which is the logarithmic function. But before we dive in and we start talking about the logarithmic function, I think it's really important for us to do a recap of the exponential function first, because often matrics struggle with the exponential function. It's been a while since you did this in grade 11, so I just want to do a brief recap of the exponential function, and then we can dive into its inverse. All right, so let's draw ourselves some axes here. And let's want black axes. Okay, there we go. Okay, so I'm going to draw myself a Cartesian plane just like that. And I'm going to use this to explain the exponential function. All right, so in grade 11, we learned about the exponential function, and we learned that it takes the form y equals ab to the x. It could be even plus p plus q, all right? But as far as we are concerned now in grade 12, when we're just talking about the exponential function and its inverse, we don't have to worry about the a and the q and the p or anything like that. So seriously, all we're actually concerned with at this point is it's in its most simplest form, which is y equals b to the x, just like that. Okay, so if I draw a graph that looks like this, if that's an exponential function, I could say that this is the graph y equals 2 to the x, right? When I write y equals 2 to the x, what am I implying the value of q is? What am I implying the value of q is? Am I clear?
Afternoon, ma'am.
Good afternoon. How are you?
I'm good, thanks. And you?
I'm fine, thank you.
You're implying that the value of the Q is 0.
Absolutely, absolutely. So I'm implying that the value of q is 0. And what I'm saying is the line y equals q is your horizontal asymptote. So in other words, our x-axis is functioning as our horizontal asymptote in this particular case. The other thing that I could say about this particular function that would be important for me is I would need to work out what my y-intercept is. Does anybody know how I would work out what my y-intercept is? Yes, Cynthia, how would I work out the y-intercept?
Afternoon, ma'am.
Afternoon.
You make x equal to 0.
Fantastic. Okay, well done. So it would make x equal to 0. So if I wanted to work out the coordinates at this particular point over here, I would say y is equal to, and that would give me 1. So I know that the coordinates at that point over there are 0 and 1. The other thing that I could also say about this particular function that might be important to me at some point is that it is an increasing function. When I say that it is an increasing function, what does that mean? What does the word increasing mean when we're talking about functions? It's got a very specific meaning. Good. Well done, Nowazi. Well done, Tomakelo. What does it mean if I say a function is an increasing function? Does anybody know? Sindiswa, go for it. Lovely. You're welcome to unmute and speak, Sindiswa.
I think we're trying to say the numbers, positive numbers.
Okay, unfortunately, you broke up a little bit there. Can you say that again, please, Sindiswa?
I think they're trying to say that that's from the negative numbers to the positive numbers.
Oh, okay. All right. I see what you're saying with that. What the word Thank you very much for that. What the word increasing actually means when we're talking about functions, as I was saying, it's very, very specific. What we're saying is that the gradient is positive. So no matter where we are on the graph, the gradient is always positive. Okay, so in this sense, we are always walking uphill as we go from left to right. Okay, so yes, Sindiswa, you're kind of on the right track there. As x gets bigger, y is getting bigger as well. Okay, so it is an increasing function. Okay, and then the last thing that I just want to talk about, because it's going to be important to us when we do inverses as well, is what is our domain and what is our range? Okay, so let's talk about our domain first of all. So what would we say our domain is in this case? Anybody want to suggest an answer for the domain? Okay, remember the domain is your set of x values. All right, so what's happening in terms of left and right? What is the graph doing? Is it going all the way down to negative infinity and all the way up to positive infinity? There we go, Norwazi. X is an element of the real numbers. Absolutely. Okay, so X is an element of the real numbers. So in other words, what we're saying is that X is going all the way from negative infinity up to positive infinity. So we could write either one of those. Okay, both of those would be correct. Good job. Okay, and then the last thing that we just need to talk about here is what is our range? This is obviously very important because we have an asymptote now. So that means that we have a value that y is not able to equal. So what we would say in this case is that y is greater than 0. Okay, or the other way of being able to write this, of course, using our interval notation or our notation with brackets, is y is an element from negative infinity. Sorry, it goes, sorry, it's not negative infinity, it's 0, beg your pardon, all the way up to positive infinity like that. Okay, so these are the sorts of things that they are definitely going to ask us to do when it comes to inverses. Just one last housekeeping thing here. There we go. Okay. So the other thing that we can do with the exponential function is this. We can take this graph as we see it over here, and we can reflect it over the y-axis. So in other words, when we reflect it over the y-axis, we end up with a graph that ends up doing that, for example. Okay, so that's not the greatest reflection. I wonder if I've got space to do another one. But anyway, we'll just leave it like that for now. It doesn't matter. Actually, I wanted to go through the same y-intercept. So I'll tell you what we'll do. Okay, there we go. That's not too bad. All right. Sorry, it's just a little bit difficult to draw that way around using my writing pad. Okay, so when this line has been reflected over the y-axis, what has changed sign? When any graph or any function is reflected over the y-axis, what variable has changed sign? Can anybody tell me? Yes, lovely, well done. Okay, so our x has changed sign. So what's happened here is essentially we've done this. We've got y equals 2, and now we have changed the sign of our x. And if you recall in grades 9, 10, and 11, our teachers were very specific about this. We were never ever allowed to write things with negative exponents. We were always expected to take our negative exponent and write it as a positive. So if I need to do that here, How would I do that? How would I write y equals 2 to the negative x with a positive exponent? Can anybody remember? How would we do that?
Hello, ma'am.
There we go, Fahim. Yes. Who's talking?
It's Amu.
Oh, hello, Amul. How are you?
I'm good, thanks, ma'am.
That's good. What would you do, Amul?
I think you say 1 divide by let me calculate, ma'am. 1 divide by 2x.
That's it. All right, lovely. Well done. Okay, so it would be 1 divided by 2 to the power of x. Absolutely. Okay, very nice. Well done. And I see a few of you are putting that into the chat as well. Very, very good. Okay, so that's going to be our equation now. Again, if we want to find the value of the y-intercept, we would do exactly the same thing as we did on the right-hand side. So we would make x equal to 0. So we would say a half to the power of 0, and we know that anything to the power of 0 is 1. So it's going to have the same y-intercept. Okay, the difference here, okay, is that this is no longer an increasing function. This is now what we would refer to as a decreasing function. A decreasing function. Okay, so as we move from left to right, okay, so as x is getting bigger, y is getting smaller. So this would be a decreasing function. Our gradient is always negative. Okay, so this is a decreasing function. Again, if we want to write our domain and our range in this particular case, this graph keeps going to left and right. So we would say that x is an element of the real numbers, or we could write it using our interval notation, so from negative infinity to positive infinity, and same story. All right, this graph has an asymptote. The asymptote is the y-axis. So here I would say that y has to be greater than 0, or if I wanted to, I could say y is an element from 0 to positive infinity. Okay, all right, Sindiswa, you got a question?
Yes, ma'am. How do we know that that is the decreasing functions? Yeah.
Okay, so decreasing functions are ones that have negative gradients, and increasing functions something that has a positive gradient. So for example, if I was drawing something like that, a parabola, all right, it would be increasing here, and it would be decreasing there. Okay,
Yes, ma'am.
does that make sense to you?
Yes, ma'am. But
Okay,
then
so
the exponent is negative. Only the exponent is negative.
yes, it's only the exponent is negative, but you can't tell from the equation whether the graph is increasing or decreasing. I mean, if you've learned that that's what it is, then that's fine. But you'd actually have to sketch it first to have a look to see whether it was an increasing function or whether it was a decreasing function.
Yes, ma'am.
Okay. All right. I think there was another question, Cindy, so maybe somebody also wants to say something about that, like you've been asking. Cynthia?
I'm sorry, ma'am. I was going to ask, how come if that side is a decreasing function, then the range is still written as x is an element of negative infinity to positive infinity? Shouldn't be the other way around.
Okay, that's the domain. So x is an element of the real numbers from negative infinity to positive infinity. So if you look at that green line, it keeps getting smaller going to the left, and it keeps getting bigger going to the right-hand side. Okay, so x continues to get smaller and smaller and smaller forever and ever. So it continues to get bigger and bigger and bigger on the other side as well. So that is correct. Okay, x is an element from negative infinity to positive infinity. Okay, and the same story, all right, y cannot be 0 and y cannot be negative. All right, so that's why we would write our range as y is greater than 0. All right, let's see if there are any other questions. And Nhlanhla?
Ma'am, for the inverse, ma'am, I just wanted to ask, how is it x is to the power of the is the exponent?
Because this is an exponential function. So in all exponential functions, x is the exponent.
Okay, ma'am.
Okay, because we're talking about the exponential function specifically. So x is the exponent.
Okay, thank you.
Okay, so all exponential functions take the same basic form that I've written over here. Y equals whatever the base is to the power of x. Okay, so b is the base, y is our output, and our input x is going to be our exponent. Okay, for all exponential functions. So these two in particular are very important for us for when we do our inverses. So what I want to do now is I want to talk about the inverses of these two functions. Okay, 2 more questions and then let's move on. Tsagofatso?
So, ma'am, if I may ask, is the decreasing function the inverse of the increasing function?
No, they're not they're not inverses of one another, all right? What I've done here is I've drawn 2 exponential functions. Both of these are exponential functions. Neither of them are inverse functions. So these are the two of the 4 exponential functions that you would have learned about last year in grade 11 and then in the previous year in grade 10. Okay, so an inverse is when we reflect over the line y equals x. It's not an inverse if we reflect over the y-axis.
Okay, ma'am, thank you.
Okay, all right. So here what I've drawn, both of these are exponential functions. The green graph is a reflection of the purple graph over the y-axis. Neither of them are inverse functions. They're both exponential functions. All right, so they're not the inverse of one another. Okay, all right. So now let's go back and talk about the inverse function. So I'm going to jump up here. Oh, sorry, I see there's a couple more questions. Amu, do you want to ask?
Yes, ma'am.
Sure, go for it, Amu.
So, ma'am, I will also able to identify if the graph is increasing or decreasing by using the quadrants.
No, not necessarily. Not necessarily. If we're talking about increasing or decreasing, so increasing means as x gets bigger, y gets bigger. Decreasing means as x gets bigger, y gets smaller. Okay, so in other words, they're talking about the gradient of the line. Are you walking uphill or are you walking downhill? Okay, so if I just go back here, if you have a look at my purple graph, right, as x is getting bigger, I would be walking uphill. Because remember, x gets bigger as I move to the right. If you look at the green graph, as x moves, or as x gets bigger, I would be walking to the right. I would be walking downhill. Okay, that's what it means.
Okay, thank you, ma'am.
Okay, no problem. So what I want to do now is introduce you to the first inverse function, all right? And it's been sketched here, and I'm going to explain to you exactly what's happened, all right? Now, if you recall when we started this lesson, this is the function that I sketched for you. Do you remember? We've just come from looking at it now. We were looking at the graph y equals 2 to the power of x. That's the one that I just sketched for you, all right? And if you recall, we also worked out what the coordinates at the y-intercept would be. It would be 0 and 1, right? What I'm going to do now is I'm going to create the inverse, right, the logarithmic function, by reflecting this graph over the line y equals x, which I'm busy highlighting in green. Remember, when I do an inverse, it's the same as me switching the x and the y around. So in other words, what happens, matrix, is this. I start with y equals 2 to the x. To do the inverse, I switch x and y. So now I've got x equals 2 to the power of y. I want to make y the subject of the equation. So I write y equals log. My base is 2 and my number was x. Okay, so that is how we write the inverse. This is the original function here in yellow. Okay, and the inverse function, this one in blue over here, is that one that I'm highlighting over there. Okay, so that's why we use the word log. Okay, because logs are the inverses of exponents. Okay, Amahle, you got a question?
Yes, I do, ma'am. When the asymptote is 0, do we always have to draw the inverse over the line y is equal to x?
Yes.
Okay.
Yes. So if you haven't done a reflection over the line y equals x, you're not talking about an inverse.
Oh, okay.
Okay, so it's only an inverse function if the function is reflected over the line y equals x. If you reflect a function over the x-axis or the y-axis, then
Yep.
it's not an inverse function. It's only an inverse function when you reflect over the line y equals x, which is the same as us interchanging x with y. Okay.
So when you have an asymptote, you'll draw in the asymptotes, and then once you're done drawing in the asymptote, you're going to reflect the graph over the line y is equal to x.
Absolutely. So in this particular situation over here, your asymptote for your yellow graph is the x-axis.
X-axis, yeah.
Yes. Your asymptote for the blue graph is your
Y-axis.
beautiful. Perfect. You've got it. All
Okay.
right, well done. Okay, and
Thank
the
you.
dotted line in between, pleasure, well done, that's lovely. The dotted line in between, that is not your asymptote, that is your line of reflection. It's the line y equals x. Okay, that's really good. Well done, Amahle. Lovely, 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 lovely. Okay, are there any other questions that you guys want to ask me before I continue? We all good right now?
Yeah, all
We're all good. Okay, so this is important, matrix, what I have written on the side over here. So let's just highlight this in a different color. We'll go with pink. Okay, so number equals base exponent.
take screenshots.
Okay, number equals base exponent. And then it can be written in log form as follows. So log base, the number is equal to your exponent. Okay, so here y was our exponent, so it's now the subject of the formula, equals log base number. Okay, so that's what I was just showing you here, and you've got to be able to write something from log form into exponential form and then do the reversal as well. Okay, Nawazi, yes, that's right. So it's not actually, I suppose it is a line of symmetry, fair enough, but it's actually a line of reflection. Okay, so it's a reflection line rather than an axis of symmetry. Okay, Nawazi. When we talk about a hyperbola, then we've got an axis of symmetry because the axis of symmetry cuts the graph in half. This is actually a line of reflection, not an axis of symmetry. Okay. All right, perfect. What I want to point out to you now, and this is what Amahle was saying. If you recall, I said to her, "What's the axis, the equation of the what's the asymptote of the inverse graph?" And she said the y-axis, and I said, "What was the asymptote of the yellow graph?" And she said the x-axis. What has essentially happened when we reflect over the line y equals x when we do this inverse is that the x-axis has become the y-axis and the y-axis become the x-axis. Right. Can you see how what was the y-intercept is now the x-intercept as well? So look here how x and y have changed around. So originally, my y-intercept on my original function was 0 and 1. If I now have a look at the coordinates at my x-intercept, can you see that it is 1 and 0? Additionally, what this diagram shows, which I think is really nice, is it shows us points that would lie on this particular line. So here on the original function, we would have the point 1 and 2. Right. If we now have a look on our inverse, that's now the point 2 and 1. Can you see, Matrix, how x and y have switched around? And that's similar to this other point over here. All right, so here is this point -1.5, and now here on the inverse function, it's at 1/2 and -1. Okay. All right, so what we could say here, right, this is important because they always ask us questions about this. Recall, maybe I'll write this in yellow, right? X is an element of the real numbers. That's our domain. And now here for our range, we would say that y is greater than 0. Look at what happens when we write the domain for our inverse functions. Okay, so now here, would it be fair to say that x is an element of the real numbers? No, here x is greater than 0, okay, because we are in the second and the fourth quadrants. It's not possible for x to be negative. Right, as far as y is concerned, it's going up forever and it's going down forever. So here we would say that y is an element of the real numbers. So can you see our domain and our range have also switched round, okay, compared to what they were before? Okay, what I would do is definitely take a screenshot of that. As it is now, I'm just going to give you guys a couple of minutes, well, not a couple of minutes, like 30 seconds, and let you take a screenshot. And then we're going to go and talk about the other inverse function. Okay,
I think they understand this work, yeah.
Everybody's had an opportunity to look at it. Now, this one looks quite a bit more confusing, all right? And that's why I started where I did, all right? It was with the revision of the exponential function, okay? So here, what I want to point out to you, in this original diagram that I had drawn down here, remember our original green graph, okay? Which was the reflection of the purple one over the y-axis. Now that green line that I've just showed you again, that's this graph over here, Matrix. I'm just going to highlight it in green for you. That's this one here. Okay, and if you recall when we first drew this, remember I said to you, this is the graph y equals 1/2 to the x. You all told me that that was what its equation was. Okay, and again, can you see here we've got the same y-intercept, right? And then we've used similar points, okay? So we've used those coordinates over there and those coordinates over there, right? Here is our line y equals x. Okay, I'm going to highlight that in pink for you. Here's our line y equals x. There we go. That's our reflection line. And now here is our inverse function, our logarithmic function. Let's highlight this guy in blue. Oops, sorry, it's very difficult to write on the writing pad from left to right over there. Okay, so there is our inverse. Okay, and then what we've done here is we've switched x and y around, and then we've made y the subject of the formula. So let me just show you again how you would do that. Okay, so if we are given originally y equals 1/2 to the x, that's our exponential function, right? For our log function, we're going to switch x and y. And now we want to make y the subject of the formula using logs. So y is our exponent. Exponent equals log base number. Okay, so that's where y equals log base 1/2 x comes from. Okay, and again, what was our domain is now our range. What was our range is now our domain. In the green graph, the x-axis was our horizontal asymptote. The blue graph does not have a horizontal asymptote. It's now got a vertical asymptote. Okay, so again, as far as our domain and range are concerned, here we would say x is an element of the real numbers, y is greater than 0. Over here, we would say x is greater than 0, and y is an element of the real numbers for the range. Okay, how's everybody feeling? Is that making sense? Please do take a screenshot. And if there are any questions, please ask. Yes, Sharon. Go for it, Sharon.
Greetings, ma'am.
Hello.
Ma'am, I wanted to ask if
Of
we
course.
write the inverse and the logarithm thingy together or just choose one.
It actually, Sharon, it depends on what the question is. So we're going to do an example now, and they give you the one graph and then they ask you for the other one. Okay, so what they could do in your June exams, trials exams, end of year exams, is they could give you the exponential function and ask you for the logarithmic function, or they could give you the log function and ask you for the exponential function. So you have to be able to work between the two. Okay.
Okay, thank you, ma'am.
All right, no problem. Sindiswa, did you have another question?
Sorry, ma'am. Can I ask if that formula which says y is equal to log 1/2x means
Yes.
is that an inverse?
Yes. Okay, so
Or
that's the equation
inverse?
of the inverse. Yes. Okay, because your logarithmic
Oh, yes,
function
ma'am.
is the inverse of your exponential function. Absolutely. Okay, so that's the equation of the inverse in this particular case. All right,
Okay,
you're
thank you,
happy
ma'am.
with that? All right, no problem. Okay, so now let's go and have a look. That's where we were before. Okay, so let's just talk about this and then we will move on. This is also something that I want you to take a screenshot of. Right, and they've said to us here, there are two types of log functions, which are the inverses of the corresponding exponential functions. All right. The other thing that is important for us here, and this is where they talk about the increasing and the decreasing. Okay. So in other words, this graph over here, that's the first log function that we looked at. Okay. Can you see that this is an increasing function? All right. Similarly, its inverse was also an increasing function. So if we have a look here, the original graph was the one in yellow. There's the graph of the inverse. Can you see that they are both increasing functions? As x is getting bigger, y is getting bigger. Okay, so they're both in the inverse and the logarithmic function, the exponential function and the logarithmic function are both increasing functions. So it would be the same thing here. All right, and then with this one, all right, so that one over there, here, a was between 0 and 1. Okay, so when they say a was between 0 and 1, we were talking about the value of our base. Okay, so in other words, we were talking about this number over here. Okay, it was a half in this particular situation. Previously over here, this one was equal to 2. All right, so here what we would have said, what we can say is that the value of our base, of our base is greater than 0 but smaller than 1. Here, what we would say about our base is that it is greater than 1. Then they just speak a little bit over here about a log expression can only be defined if a, so the a represents the base in this case. So they're just using the letter a to represent the base. All right, so the base can either be bigger than 1 or it can be between 0 and 1. Okay, so a cannot be negative, it cannot be 0, and it cannot be 1. All right, that's really, really important. Okay, so why can the value of a, why can it not be 1? Anyone got any idea? Why could a base not ever be equal to 1 in a function like this? Anyone got any idea? If I had a function and I said y equals 1 to the power of 10. Lucinda, what do you think?
Hi, ma'am.
Hi there, how are you?
I'm good, ma'am.
I'm fine, thank you.
Ma'am, I think the reason why what is the question again, ma'am? Please repeat.
Okay, so what I was asking is why can the base not be equal to 1?
Because any value to the base 1 is 1, still gives 1.
Exactly. So in other words, we're not going to end up, 100%, we're not going to end up drawing an exponential function. If we talk about y equals 1, we're talking about a horizontal line, aren't we? That would be the line y equals 1. It would not be an exponential function. So that's absolutely brilliant. Okay, well done. Good. Okay. Is it possible for our base to be equal to 0? Yeah, exactly. It doesn't change anything. Okay, our base cannot be 0 either. Okay, so our base cannot be 0. We cannot have a 0 base. We're not going to say y equals 0 to the power of something. Okay. No, there we go. Good. All right, lovely. Okay. And our base can also not be negative. So in the CAPS curriculum, we do not allow for negative bases when we're talking about functions. Okay, so that's just a restriction in our curriculum. The other thing that they point out to you over here as well is that x cannot be negative or 0. Okay, so x is always going to be positive. And again, if you have a look at where these graphs, where these log functions are sketched, they are sketched in quadrants 2 and 4, where x is positive. Okay, so that's why x cannot be negative. Okay, so your number x, so in other words, the x that they're talking about is this one. So if I say y equals log, and then my base, if I use the letter a to represent my base, x, it's this x over here. Okay, that cannot be negative or 0. A, this number over here, that's my base. It cannot be negative or 0 or 1. Okay, so this is what they're referring to. So let's just add that in here for you guys. So, or you've actually got it here in front of you. Okay, so this cannot be negative. It cannot be 0 and it cannot be 1. Okay, this x over here cannot be negative. And it also cannot be 0 as well.
Screenshot, my people.
Yes, absolutely, very important. Okay, let's go and have a look. Okay, at this example. All right. So they tell us the function f of x, and that's just another way of writing functional notation. Don't be put off by that. This means exactly the same as y, and it means exactly the same as if I did that. Okay, so f of x equals log a x passes through the point 4 and minus 2. The first thing that they want us to do is determine the value of a and hence the equation of f. All right, so now we are talking about a logarithmic function. If we want to work out the value of a, all right, what it means is that we need to be able to sub into our equation. That's why they've given us this point. The 4 represents our x. The minus 2 represents our y. Okay, so if I'm going to go and sub into this, I would like one of you to tell me what it is you think that I should write. Where should I put the 4 and where should I put the negative 2? Anyone got any idea? Yes, Tegofatso. Go for it. Tegofatso, you're welcome to unmute.
Ma'am, I think where it's written f at x, we have to replace it with -2. Then
Lovely.
where there is x, we replace it with +4.
Lovely. Well done. That's perfect. Okay, great. So we're going to put -2 over here, like you said, log A over there, and then we're going to put our 4 over here, our number. Okay, now we need to be able to go backwards. Okay, so remember, okay, this is very, very important. Okay, I'm just going to write this again on the side for you. Okay, so our base to our exponent is equal to our number. Okay, then our exponent is equal to the log base of our number. Okay, very, very important for you. Okay, so what we are looking at now is this. This is our exponent. The log of our base gives us this number. Right, so now I have identified that A is our base. So A is the base. The exponent is -2. Our number is 4. Okay, has everybody got that?
Thumbs up, thumbs down, my people.
Yep.
Are we getting
Thumbs up,
it?
thumbs down.
Yeah, and Anati, it's best to take a screenshot if you think it's fast. I see you're writing fast. Then you can also take a screenshot first.
Yes. Oh, good. Okay. All right. So there's some thumbs ups and some thumbs downs. I know this is a little bit confusing at first. I'll just do it one more time before moving on. What are the people saying, Yolanda? Is it making sense or is it a bit confusing? Okay, so we've got -2 equals log A 4. Okay, so it's been written in this format. What they want us to do is they want us to write it in that format. Okay, so this over here is our base. Okay, so that's why I'm writing A as my base. Okay, this over here is my exponent. Okay, so the -2 is my exponent. So here, there's the -2, my exponent. All right, and my number is the 4. 4 is the number, so equals this number. Okay, so this has to be equal to 4. So what I've tried to do there is color coordinate it for you. The base is in green, the exponent in yellow, and the number in blue. Okay, everybody happy with that? Okay, hopefully that makes a little bit more sense. Okay, and then what I've got to do here now is I've got to do a little bit of manipulation. All right, remember I'm not allowed to write things with negative exponents. So I'm going to write this as 1 over A to the power of 2 is equal to 4. What I can do here is I can rewrite 4 as 2 to the power of 2. So if I've got 1 over A is equal to 2 to the power of 2. Okay, that means that I've made my bases the same. It means that 1 over A is equal to 2. And now I can cross multiply, and that means that A would be equal to 2 in this case. All right, everybody happy with that?
Sorry, Teacher Lee, is it the other way around or am I being confused? So
Sorry,
A
am I
equals
being
to...
stupid? Sorry.
No, you're not. I'm just...
Did I make a mistake?
You know, when you have to find A, you said A
Yes.
equals to 2, but 1 over A equals to 2. So
What
A
did I
cannot be,
say?
you said 1 divided by A equals to 2, and then
Sorry. No, you're quite right. I beg your
Oh.
pardon. I was being stupid. Sorry. Hang on a second. It's just, sorry, guys. My apologies. What was I thinking? Okay, so this should be 1 over a squared, right? And that would be equal to 4. Then I would cross multiply, so I'd get 1 equals 4a squared. So now what I want to do is divide both sides by 4. So a squared would be equal to 1 over 4. Sorry, and now I need to take the square root on both sides. Okay, so a would be equal to plus minus the square root of 1 over 4. But remember, a cannot be negative. Okay, a cannot be negative. Okay, so therefore a would be equal to 1 over 2. Okay, sorry about that. I don't know what I was doing for a second. Okay, sorted. When you, Cindy Swift, you say if you're using a second formula, will I get the same answer? So how would you do this differently, Cindy Swift? What other formula would you use?
Like, ma'am, if I'm using that formula that you wrote, exponent is equal to log base number, will I get the same answer?
If you use, to say that again, sorry, you broke up. If you use?
That formula that you written down, exponent is equal to log base number.
Yes, so that's what you were given. Okay, so you were given exponent equals log base number. So the only thing that you can do that is write it as base exponent equals number. There's no other way that you can do that. Okay, there's only one way that this can be done. Okay. All right.
It's only one way.
Only one way you can do that when you're working with inverses. Okay, only one way that you can do that. All right, so if they give you exponent equals log base number, you can only write base exponent equals number. There's nothing else that can, there's no other way to do it. Okay. All right, so now determining the equation, what we would end up with here is so using the inverse function like that. Right, now in this case, the inverse function is going to be an exponential function. All right, so the inverse is going to be an exponential function. So this is going to be the graph of to the x like that. Dikeledi, you had a question?
Greetings, ma'am.
Hello.
How are you, ma'am?
I'm fine, thanks, and you?
I'm good, thank you. Ma'am, about the answer, should it always be in its simplest form?
Yes, it must always be in its simplest form.
So if the equation or the expression should was to be around 3 marks and we left it as a fraction, how much would we get?
Okay, so when you say leave it as a fraction, there's no other way that you could have written this in this particular case. So you're not going to be working with fractions that can be simplified. You're not going to be working like 2 over 4 or 3 over 6 or something like that. So I wouldn't worry about that. But yes, you should always try and simplify if you're working with fractions. Okay.
Oh, okay, ma'am. Thank you, ma'am.
All right, no problem. Okay. So Bonolo, is it necessary to put the answer in decimals instead of fractions? Generally not, Bonolo. We wouldn't write it with a fraction. So we wouldn't say a equals 0,5, but I mean, you can if you want to. That's absolutely fine. Not a problem. Okay, yes, so Nolwazi, the calculator only gives you the positive answer. It doesn't give you the negative answer. Okay, but whenever you do a root, you're always going to get a positive and a negative answer. In this case, the negative answer just does not apply. Okay, then they want us to draw neat sketches. They see there's a no problem. Omogolo, do you want to ask a question?
Good afternoon, ma'am.
Good afternoon. How are you?
I'm good, and you?
I'm fine, thank you. What's your question?
Ma'am, I wanted to know what happened to that log.
To the log?
Yes.
Okay, so the word log is not there anymore. Okay, so when we're writing something in exponential form, we're not using the word log. Okay, we only use the word log when we write something in logarithmic form.
Oh.
Okay.
Thank you.
All right, no problem. All right, so let's just quickly finish this question off. And again, you can see here there are questions about domain and range, increasing, decreasing, etc., etc. All right, so now if we needed to sketch these graphs very quickly, sorry, because I can see our time is running out. Which time is always an issue for us, isn't it, guys? Okay, so let's pop that over there. This is part C. All right, now, if I draw my original, well, not my original, I draw my exponential function like that. So this is going to be my inverse function in this particular case. That point over there is 0 and 1. The other thing that's important for me to always put in is the line y equals x. So let's label that. And then let's put in our there we go. And then that point over there would be 1 and 0, and that's not going to change. And that was our original graph, F, like so. Okay, so what we would need to label are intercepts with axes, our line y equals x, and then our graphs. Okay, so I have done that now for part C. So we've done A, we've done B, we've done C. They just wanted us to write down the domain and the range. So let me just do that quickly. So here we would say for D, for our original function for F, okay, we would say that our domain, so X is greater than 0, Y is an element of the real numbers. For the inverse function, we would say that X is an element of the real numbers and Y is greater than 0. And the last thing, write down the values of X for which the functions are either increasing or decreasing. So as far as we are concerned over here, let's just, sorry, I was hoping we would be able to do these questions as well. Go. All right. So write down the values of X for which they are increasing or decreasing. Okay, so here, when it comes to our original function, which is F, okay, it's going to be increasing and it's going to be increasing for where X is greater than 0, I think.
Yes, it has to be.
Yes, it has to be
X
increasing
greater
for
than
X
0.
is equal to greater there. And then as far as our exponential function is concerned, it was increasing for when X was an element of the real numbers. Okay, all right, so let's just see there. I think there might be a couple of questions.
I think Sharon's hand has been up. So we
Okay,
can start with
Sharon,
Sharon.
go for it. Go for it.
Ma'am,
Yes, hello.
the example that we just did,
Yes.
we had said that A cannot be negative. So is
Yeah.
that always the case, or
Yes.
just when we total?
No, 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 no. A cannot be negative. So the value of the base cannot be negative.
Okay. Thank you.
Okay. No problem. Yolanda, I also just wanted to tell you load shedding is starting for me at 6. So
me too, but
okay.
I'm sorted. I'm sorted.
Okay.
Don't worry.
Are you
Yes.
sorted? Okay. All right. Now I'm going to go and change my battery over now. Okay. So I'm going to be disconnected for a little bit.
No problem.
But I'll go and do that now. Let me just ask Sindiswa, can I please repeat B? Okay. So for B, I was writing down the equation of the inverse. All right. So the inverse of the log function is the exponential function. Okay. So in other words, I'm working backwards, Sindiswa, from if I've been given an original function and my function is log half x, then the inverse function of that is going to be, my base is going to be a half to the x. Okay, that's where it comes from. Okay.